So today we are talking about solving systems by substitution. So substitution is the process of replacing the variables with a number or an expression. So you guys have done this before when you're given the value of x and plugging it into an equation or an expression and solving. It's kind of the similar process. So our steps for solving systems by substitution are to first, we're going to choose the equation and solve for a specific variable. So we're going to choose an equation and either solve for x or solve for y. So that's our second step. We're going to get either y by itself or we're going to get the x by itself, whichever is easier for that equation. Once we get the y or the x by itself, we're going to substitute what y is equal to or what x is equal to into our equation. So we're going to substitute that into the other equation that we did not use yet. Once we substitute it in, we're going to simplify and solve for the variable in that equation. And that's either going to give us our x or y value, depending on what variable we're solving for. And after we get our x or y value, we're going to plug that number in and solve for the remaining variable. When we do this, it is possible to have no solutions or infinite solutions. So remember, if we're looking at those on a graph, if there's no solution, that would mean that they are parallel lines and they never cross. And if it's infinite solutions, that's when they are the exact same line. So it is possible when we're doing this by substitution, just like when we're graphing, to have no or infinite solutions. And once we're done with that, we can always check our solution by plugging in our x and y value that we found and make sure it makes a true statement. So our first example, we're going to take a look at number 1 says x plus y equals 5 and y equals 3 plus x. So we're going to solve this without graphing, assuming we don't have a graphing calculator. And our first decision is which one of these equations are we going to get to have a variable by itself. So looking at these equations, we already have y by itself here, so I don't have to solve for y because it's already by itself. So what I'm going to do is take what y is equal to, and I'm going to replace the y that's in the other equation. So I'm going to substitute in that value for y. So when I do that, instead of x plus y equals 5, we're going to substitute in that 3 plus x for y. And we're going to solve for x. So all we did was replace y with the value that y is equal to, that 3 plus x. From there, all we have to do is solve normally. So I'm going to go ahead and combine like terms. I've got 2 x's, so that's going to turn into 2x. And I've got a plus 3. So now that we've simplified our expression on the left side, we're going to go ahead and solve for x. So I'm first going to subtract 3 from both sides and get 2x by itself is equal to 2. And then I'm going to divide by 2 on both sides. And when I do that, I get x is equal to 1. So this is our x value of the ordered pair. If we were to graph it where our lines cross, that's our x value. Now that we found our x value, we're going to go back to one of our equations and we're going to plug in the x value to find our y. Since this equation is already in y equals format and we're solving for y, we're going to use that equation. So I'm going to say y is equal to 3 plus x. But now we do know our x value, so I'm going to plug that x value in. Instead of x, we're going to put 1 and then simplify. So for our ordered pair where our 2 equations cross on the coordinate plane, we're going to have an x value of 1 and a y value of 4. So that is the ordered pair where those 2 equations cross. We're going to go ahead and do number 2. So for number 2, again, our first step is we're going to go ahead and choose which of these 2 equations we're going to solve for a variable. So looking at our variables, the only one that doesn't have a coefficient is x, so it would be easier to isolate that variable because we have less manipulation in our equation to do. So I'm going to go ahead and get the x by itself. I'm going to rewrite my equation, 3y plus x equals 7. And I'm just going to move that y term to the other side to get my x by itself. So now we have x by itself, and I can use that value for x and plug it into the other equation. So I know x is equal to negative 3y plus 7. So I'm going to use the other equation that we didn't use yet, which is that second equation, 4x minus 2y equals 0, and I'm going to plug in that value for x. So instead of x, I'm going to write what x is equal to, which is negative 3y plus 7. And then write the rest of my equation down. And then I'm going to go ahead and simplify my expression and solve for y. So my first step here is to distribute that 4. 4 times negative 3 is negative 12y. 4 times 7 is 28. Bring down the minus 2y and the 0. Then we're going to combine like terms. Negative 12y and negative 2y gives me negative 14y. Plus 28. And then we're going to go ahead and solve for y. So I'm going to subtract 28 from both sides to isolate the y term. And then I'm going to divide by negative 14 on both sides. And when we do that, we get y is equal to 2. So that is our y value for our ordered pair. And now that we have our y value, we're going to go ahead and plug that y value into one of our equations and solve for x. Since we already got x by itself in that first equation, I'm going to plug in the value for y here to make it easier to get x by itself. So I've got x is equal to negative 3y plus 7. I'm going to replace that value for y that we found, which was 2, and I'm going to simplify. Negative 3 times 2 is negative 6, and then plus 7 gives me 1. So my x value for my ordered pair is 1, and my y value for my ordered pair is 2. So these two equations, if I graph them on a coordinate plane, cross at the ordered pair 1, 2. We're going to do 2 more examples. For that first example, we've already got a variable by itself.